So my name is Henrik. Like I said, I'm a cloud-native advocate working at Dynatrace a bit 4 years now. I'm also an observability geek. I love observability in general. I'm a CNCF ambassador, and prior to my experience with Dynatrace, I've been spending my career doing performance engineering, so testing, breaking, tuning, having fun. And that's why I still love the performance engineering practice, because I think it's an amazing practice to learn things. So I try to produce content when I have time on a YouTube channel called PerfBytes on the bottom. And otherwise, I started 3 years ago a channel called Is It Observable? Everything about observability in general. So check it out, it's there. And it deserves feedback. If you don't like it, let me know so that I can improve my content. So let's start. Small disclaimer. A long time ago, in far, far away, in the galaxy, there was a lot of service meshes doing war. They only want to control the networking in our Kubernetes environments, but we didn't know which one we should trust. So this presentation here, I made a lot of tests to test it out, their solution, and I can guarantee that I didn't break any gorilla, any boats, any cube were destroyed. I was very gentle with them. And the intention of this talk is to not blame any of the project. It's on the opposite, give feedback to these different projects that are under the CNCF umbrella, and also give you some tips about their solutions. All right, so let me introduce the different clan in this presentation. So we have Kuma coming from the Kong, has been doing a lot of things on the gateway side, and they have a service mesh called, under the CNCF landscape called Kuma. We have the Linkerd team. It's the company behind the scene is Beyond. So they do mainly HTTP and gRPC. It's the bounty hunter for HTTP GO requests. Then we have Cilium. So they drive pretty well. You'll see that I put it this pilot because you'll see there's something behind why I choose that character. And then of course we have Istio. The Y is Istio, that we've been out there doing great things, so we can trust him. He has good reputations within the Jedi. And we have his young Padawan, ambient mesh. So the idea here is that we're going to compare those solutions and figure out who is the best one, depending on our needs and our implementations. But there's a new hope. I don't know if you followed. Pretty sure that you followed, everyone. There's a new hope in the galaxy. Then it's the Kubernetes, the Gateway API. The Gateway API is there to simplify our journey, providing CRDs that will be common to all those solutions that then we can configure only using those CRDs, and we don't have to go through those specific CRDs of each individual solutions. So they do, of course, mainly today ingress, load balancing, traffic splits. There are a couple of service meshes features, but you see that not all of them are is on the way. There's a Gamma initiative behind the scenes to add more features on top of that. So let's be very patient, and in the future, we would have more options to configure all those rules and those policies using the Gateway API. So just for those who have never heard about the Gateway API, there's the gateway, and then you define an HTTP route, or gRPC route, TCP route. Depending on the protocol you use, you will use one of those CRDs. And then, of course, when you use them, similar to the ingress that we used to use in the past, there's a gateway class where you say, oh, this is going to be handled by Nginx or Istio or Kong or Linkerd. So this is how it works usually. But, so it's very easy to configure, nothing special. But you see that there's a but, there's a no. Why a no? Because you see that a couple of features are not there, not implemented, so you end up doing part of the configuration with the Gateway API, part of the configuration with the custom CRDs of the service mesh. So it's a bit inconvenient as of now. So you need to know both worlds, which is kind of a bummer. So if you stay with me, I hope, during the next 20 minutes, 25 minutes. So we're going to first cover what do we expect from a service mesh in general. And then we're going to compare each of those solutions, looking at the components that they use, the design experience, because we'll see that we will have to design, of course, different policies, and the observability that they bring, and how complex it is or easy it is to configure the observability. And then I've did a benchmark, so I will share some results about how much latency they are adding in our applications and the CPU or memory consumptions that they need. And at the end, I will give you some conclusion. So you have to stay until the end to get the conclusion. So don't try to run away. Wait 20 minutes before run away. So let's start with the components. For those who never heard about a service mesh, well, it's super easy. There is a control plane where you're going to basically configure, and the control plane will reach out to proxies, because you need a proxy at the end, and to define the different policies that you have defined, so ingress rules, traffic split, whatever you want. And then in the bottom, your application plus the proxy are called data plane, and then which is great is the proxy is going to be handling the traffic that you have with your workloads, and they are providing out of the box telemetry data, so logs, metrics, and traces. So without doing an effort, you get some details about what's going on under the hood on the traffic level. And then, of course, you need a proxy. A proxy you need, and there is two models in the market. There is the sidecar model, which is the most well-known format because it's been out there since many years. And now there's the new model, sidecar-less, where you don't need a sidecar. So the sidecar model is, I would say, they have some downsides in the sense where you need to add an extra container to your workload. So your workload has been mutated. They add a container, sidecar container with your proxy, which means at the end, if you need to have the service mesh, you need to restart your workload. No transparent routing without any restart. And then you have the serviceless, the sidecar-less, sorry, where here you have two types of proxy involved. Usually there's a layer 4 for TCP communications, and then you will add another probably proxy for the layer 7, so HTTP, gRPC communications on the top of that. So if you go to those solutions, we have, of course, solutions that are sidecar-less and others that require a sidecar. So Kuma, Linkerd, and Istio requires a sidecar. And they use, for most of them, Envoy, except for Linkerd that has their own proxy supporting only HTTP and gRPC traffic. On the sidecar-less, so I would say Cilium, they have a Cilium mesh, and ambient mesh. It has defined a new ambient as a new proxy called Z-tunnel that is mainly designed for TCP communications, so layer 4 communications. So let's cover the force that you expect from a mesh perspective. So there are a couple of features that you need when you're handling microservices in general. You don't want to handle those type of rules in your code, so that's why you rely on a service mesh to do that. So you want to basically handle the incoming and outgoing communications, or egress communications. You want to have a mutual TLS, so encrypt the traffic between the pods. You want to have the retry logic if in case there's a problem. Any security, so authorization policies involved, rate limiting, circuit breaker, and of course observability. So that is basically what we expect in general from a mesh. And in those solutions, most of them, at least the sidecar one, they support all the features that you have in the, I would say, the force of the mesh. The sidecar-less doesn't have all the features as of now. They have few of them that are covered. I think I made a mistake on the timeout. Timeout is supported with the HTTP route from the gateway API, but the other one doesn't have the full-fledged features, which means you have part of the features, not everything. So depending on your needs, you have to consider that aspect as well. Now, let's cover the design, because those features require some specific design. So you need to understand how those solution works. Starting with Kuma. So Kuma, if you never touched a service mesh, Kuma has advantage. It's super simple. You have a CRD for each features. I want to do timeout. I'm going to use the mesh timeout. I want to do traffic split. I'm going to use. So it's super simple in that sense. And the way it works, you have a gateway on top. So either you use the gateway API, if you want to use it, of course, or you can use their CRDs. And they have this concept. There's a mesh. In the mesh, you have a data plane, and then in the data plane, you have services. So then, when you apply a policy, you say, where do I want to apply it? In the mesh, in data plane, or on a service level? And then to add your application in the mesh, as expected, you just simply need to add an annotation to your workload, or your namespace, and that's it. You're part of the mesh, and the routing will happen. Linkerd is support, of course, the gateway API. It has different type of concepts. It has this notion of server, so you need to define exactly all the routing of your application, which is make the experience more difficult. That's why they have a CLI called Linkerd, where you can inspect. And by inspecting, it could guide you and create those server objects, which is interesting, again. And on the most of the mesh perspective, you can configure the load balancing, the traffic split with those objects. So it's very simple. And then on the bottom, on the proxy level, they have specific objects that will touch the Linkerd objects, Linkerd CRD, so then you can configure the proxy locally on the workload. To add an application on the mesh, you don't add an annotation on the namespace, because for some reason they don't support it. You have to add it at the workload level, which is kind of a bummer. That's why they have this feature with the Linkerd CLI called inject, so they can basically add on the fly those annotations to your YAML files and apply them. So I think from that perspective, it would be so much easier to have it on a namespace level. Cilium, so Cilium, I would say I have added them in the list because they have Cilium mesh, they call it mesh. But you will see that the way they're handling it, it's mainly through their networking features that they have with Cilium, using eBPF, so very fast. You can do Cilium network policies to authorize traffic or not on layer 7, layer 4. They have this integration with Envoy, so you can add also an Envoy, so it's add an extra daemon set called Cilium Envoy. And you can do most of the configuration using the gateway API. But for the rest, there's almost nothing. They have this notion of Cilium Envoy config, where technically you can configure similar to other objects, the proxy, but maybe I didn't get it, but I never succeed to do it. So if you succeeded to do it, let me know, because I would be very interested to know how to do this. Istio has very well-known objects, so, destination rule, virtual services. You need to define the virtual services, the destination rule or service entry, but you can do everything with the gateway API. Most of the features of Istio is configurable through the gateway API, which is nice. And then on the proxy level, they have this Envoy filter, where you can configure the proxy level from the Envoy filter. And it's quite easy. I didn't find any problems for this. To inject the workload, to inject your workload into the mesh, you need to add a specific CRD, specific annotation, sorry, called Istio injections enabled. You can add it on an namespace or on a workload, and that's how you add the application into the mesh. Ambient mesh is going to be 100% configurable the same way as Istio. So if you have experience with Istio and you want to move to ambient, there's nothing complicated. And they have this notion of Z-tunnel that do as a daemon set that would manage all the GCP traffic of your node. And then you can add, if you need to have some layer 4 rules, for example, request timeouts, circuit breakers, like this, you can define a waypoint. So in a namespace, it will add an extra workload in your namespace to manage that type of communications. So it's very easy. And then similar to the other product or solutions, to add something in the mesh, you simply need to add a notation. So one is just to add the actual namespace into the ambient mesh. And the other one is you can define at the workload level that, oh, I need to use this specific waypoint. So then the application will know that you will use the Envoy to manage the layer 7 rules. So at the end, if you look at this, I would say I looked at the documentation perspective and the experience to design things. I think from just easy to use, Kuma is just wonderful. It's so easy to do it. I'm not saying it because there's someone from Kong in the room. Not at all. But from a documentation perspective, it's easy to use. The feature coverage is perfect. And the gateway API support is here. I think Istio, because it's been out there and I'm used to it, for me, it's kind of obvious. And ambient mesh, transitioning from Istio to ambient mesh is super easy. The only thing is it doesn't have the full fresh coverage. If you have some policies in Istio and you want to move to ambient, consider that you will have no support. Now let's move on to observability. So observability, where the service meshes in general, like I said, they provide lots of data in top of your application, which is wonderful. So let's see how you can configure that. In Kuma, you have dedicated CRD, like before, mesh traces for traces, mesh metrics for metrics, and mesh access logs for the access logs. The control plane, by default, will produce metrics, and you can also configure it to emit traces, which is fantastic. And then Kuma provides a UI, so if you want to see if your configuration is done properly, you have this UI, which is kind of nice. And the great thing is they support OpenTelemetry. They are not saying that we support OpenTelemetry, but they do partially. They do OpenTelemetry for metric traces and logs. So then you can use it, and you can get you can trust that you will get data to your collector or to your backend. Linkerd. Well, Linkerd here, by default, they will expose some Prometheus metrics, but they have extensions called Linkerd Wiz. And when you enable it, then it's simpler to collect the data. They provide a UI on top of that. Then if you want to do traces, they have another extension called Linkerd Jaeger. But they don't do real OpenTelemetry. They don't do OpenTelemetry logs. They don't do OpenTelemetry metrics. And they don't do traces with W3C trace context. They use the Open Tracing trace context, B3. So if your application is fully fledged OpenTelemetry ready, then the traces will never be attached, which is kind of a bummer, to be honest. And then control plane, they expose metrics as well, but they don't expose more data. Cilium, well, Cilium, like I said, they don't do traces. They only do metrics and logs. And if you want to have a full-fledged details of what's going on the network level, then you need to add Humble. Humble provides so much details, very related to the networking side, more than their service mesh, I would say. But, and they don't generate traces. So you have to use their UI, or you have to expose metrics. So you have some observability, but less compared to the other products. Then I've grouped Istio and Ambient Pesh, because at the end, the logic of configuring this exact same thing. You have the telemetry objects to configure traces, metrics, and logs. You can also do it using their mesh config when you deploy it. You will also configure it automatically. The control plane expose a lot of metrics in a Prometheus format. And if you need a UI, they have an extension called Kiali, where you can see the traces, the dependency of your meshes, and it gives you the right details. And again, similar to Kuma, they provide real OpenTelemetry support. So which means if you enable OpenTelemetry traces, then you will get the traces in your app from each proxies. So at the end, on the observability side, I would say the two solutions that are a bit limited, I would say it's Linkerd and Cilium, because first they have a limited support of OpenTelemetry or no support, and the configuration aspect is more complicated compared to the other solutions. All right, so now let's cover the most important piece of this presentation, which is performance. So when I started this I did that benchmark, I said I would be really interested to get the actual weight and that those meshes is adding to your applications. So how much latency do I get when I add an application to the mesh? So here I'm not going to measure every latency on every single microservices. What I'm doing is I'm sending an HTTP request to an application, and then I measure how much latency added when I have 11 or 12 proxy involved in the transactions. So you will see that I will provide those numbers. And then the other aspect is resources. We mentioned there are sidecar and sidecar-less. How much resources would I consume? That would be interesting to get those numbers. So to achieve this benchmark, then of course I had to, so there's a QR code, so if you want to rerun it, this benchmark in your environment, feel free to do so. So to measure the actual difference between having no mesh and a mesh, I did a test without any agent, nothing, no mesh involved. Then I did one test with Kuma with no policies defined. Then Kuma with some policies, and I decided for this benchmark to use two policies, request timeout and rate limits. And then I did the same thing with Linkerd, without any policies and with the policies. And then I did same thing with Cilium. So I removed the line with the policy because it didn't work. So there's no support of rate limiting with Cilium, so I decided to drop this test out of these results. Istio did the same thing, so with the policy, without the policy, and of course Ambient, I did the same thing. I removed the line because they don't support also rate limiting. And that's why I decided to remove the line. So in the architecture, you have, of course, it's going to be, I don't describe all the architecture of every single test, but there will be, of course, the mesh involved. And then I've added the OpenTemperature demo. So that will be the main application used to do the benchmark. And I do a normal test with the load test as well. And then I'm adding 2 extra applications, the Hipster Shop, Easy Trade. So then there's traffic, and those proxies is actually used. And then, of course, to collect the data, the metrics, the traces, I use the collector, OpenTemperature collector. And I use the dynatrace operator just to get the actual memory usage of those workloads. All right, let's start with the results. So I did a constant load, which is 30 minutes of test with 50 users on each of those applications. And then I've done a load test, which is 2 hours, where I have 50 users added every 30 minutes. So now I didn't add here, sorry, it's another benchmark. I added the load test so you'll see the results. So if you look at the numbers, so here the numbers are basically from the front end. The front end in the OpenTemperature demo, you have 10 microservices. So there's a lot of microservices with a lot of proxy involved in those response times. And if you look at the numbers, Cilium, if you use the BPF routing, they don't provide any latency, 0. Linkerd, I was surprised, honestly, from a proxy, for a proxy model service mesh, they're only adding 2.55 milliseconds, which is kind of low. And then you have, of course, ambient mesh with 3.69, and then Kuma is going to be faster with almost 6 milliseconds. And last we have Istio with 6.5 milliseconds. In terms of resources used, so I have on the bottom here the proxy. Of course, the solution using a sidecar will consume more because it's the sum of all the proxy involved in the tests. So the one that is consuming more is Kuma in terms of memory. And then, of course, Istio. And then down on the line, you have Linkerd, Cilium, and then on the lowest line is ambient mesh in terms of memory usage. And then if you look at the CPU utilization is Istio, the top layer, and then it's going to be Kuma, Linkerd, Cilium, and then ambient mesh. And then if you look at the control plane is Linkerd. Linkerd consumes most of the CPU and most of the memory at the end. Now, if I do a load test without any policies, then there's a slight difference in terms of latency introduced. So Cilium add a small amount of latency in the transaction, and then you get the same order. So Linkerd at the same level as ambient mesh, and then you got Kuma, and of course, last is going to be Istio. And then the similar behavior that we had before in terms of memory consumptions and CPU consumptions on the proxy level is the same. You can of course see that the sidecar model is consuming more CPU depending on the load. Of course, no surprise. And on the control plane level, we start to see that Kuma is having spikes of CPU. I have no explanation why, but you have those spikes of CPU during the tests. But otherwise, Linkerd is still the most expensive control plane. Now, if I add those policy, what will be the impact? Well, on the response times, the order is still the same. We still have Linkerd on the second position, still ambient mesh on the third position, and still Istio on the last position. And on the behavior of the proxy, it's the same. We still have the same type of behavior. I can see that Istio is consuming the same amount of CPU compared of Kuma, but for the rest, it's the same. And now if I do the load test with the policies, same results, I would say, nothing special. The order in terms of transaction, we still have Linkerd and ambient mesh at the same level, and Kuma always better than Istio. So if I have to conclude, I would say from a latency perspective, Cilium is the top, Linkerd and ambient mesh is the second, and then we have Kuma, and last Istio. Proxy usage, I would say that the proxy CPU, I made a mistake here. The proxy CPU is consuming a bit more on the Kuma side and on Istio side, which so there's a small mistake on this line. I figure out. So at the end, I would say depending on your need, there's no clear winner. I would say the only conclusion I would say that if ambient mesh was supporting all the full-fledged features that we need for service meshes, then clearly in terms of response times delivered, in terms of features delivered, in terms of resource they use, it's the best. In terms of experience to start using a mesh, I think Kuma is nice because it's very easy to configure. You get everything without any minimal effort, so I think it makes sense. You know that you will have some extra milliseconds added to your transactions, but it's acceptable. Linkerd, I would say, even if it's quite efficient in terms of response times, it's just that the configuration perspective is painful. I didn't enjoy configuring Linkerd from my perspective. And from the observer perspective, they don't add so much detail. So again, it's a balance for you. If you use only HTTP and gRPC, then maybe Linkerd could make sense. But again, my conclusion says if ambient mesh was supporting everything, then go for ambient mesh. Small teaser to the channel. I did some content about Kuma, Istio, ambient mesh, gateway API. It's out there. I may produce a content where I summarize those results. Again, if you don't like the content, let me know so I can improve. If you like the content, let me know as well, so then I can be proud. And yeah, if you have any questions, I will be very eager to get questions from you guys. No questions? As Cilium is doing so first, I didn't say that on the conclusion, but from, yeah. So why Cilium is not adding latency? Okay. So first of all, one thing before I answer the questions, I didn't say on the conclusion, I forget it. So for me, Cilium is not really a mesh. It's more a networking component. I think they have a mesh feature on their documentation, but they don't have the full-fledged coverage. I think they are really good on I think it's a complementary solution for your mesh to secure a bit more than really using just Cilium for a mesh perspective. But to answer your question, why they are so efficient, I think they're not using IP table anymore. They're using the eBPF to do the routing, and I think that's how they are getting better zero latency to applications.
When you increase your service depth calls, like when that service path is significantly larger, do the results change at all?
I only use as a reference the OpenTelemetry demo that has 6 or 7. So that was the actual results. It could be interesting to test it out with a application having 3 workload to see if it has less impact to the transaction. That is a good use case. But yeah, I never thought about this feature. Yep. So the gateway API works with Cilium, yes, but so it supports with the gateway API. I think the mesh support from Cilium is only with the component provided by the gateway API. If you have a feature that is not supported by the gateway API, then there's nothing behind the scenes. Compared to the other solution where if it's not supported, you still have a workaround with another components. That's the main difference, I would say. One thing also, if you enable observability in the meshes, it's awesome. You get a lot of details. But just keep in mind that it will add one span for incoming and outgoing communication of each individual services. So you may start to think about, I should maybe sample a bit more because I will basically double or triple the number of spans that I produce. So if you're very worried about the costs and the volumes of observability that you will get from your applications, then consider that the meshes will probably multiply by 2 the volume of spans that you have in your own environment. But yeah, that's a small note because I didn't mention that. Any other questions? Guy, did I kill you or? Yeah, I'm sorry. All right, so then if no questions, thank you.